Imagine, if you will, a day like any other on our planet. The sun rises in the east, casting its warm glow across the land. Birds sing, people go about their daily routines, and the Earth spins effortlessly on its axis. But what if in an instant this rotation ceased? What if our world suddenly stood still? The very thought seems impossible, the stuff of science fiction. Yet the consequences of such an event are rooted in real physics and paint a picture of unimaginable catastrophe. The Earth's rotation is not just a measure of time, it's a fundamental force that shapes our planet and everything on it. A sudden halt to this rotation would unleash a chain reaction of events, each more devastating than the last. The very fabric of our world, from the atmosphere above to the oceans below, would be ripped apart. To comprehend the true scale of this disaster, we must first understand why our planet spins and what that rotation means for life as we know it. The Earth's rotation is a relic of its formation, a cosmic dance that began billions of years ago. Imagine a vast cloud of gas and dust swirling in the emptiness of space. As this cloud coalesced under its own gravity, it began to spin faster and faster, much like a figure skater pulling in their arms. This spinning motion, conserved over eons, is what drives the Earth's rotation today. But the Earth doesn't spin alone. It's locked in a delicate gravitational ballet with the sun and the moon. This intricate interplay of forces not only dictates our planet's rotation, but also governs our seasons, tides, and the very stability of our environment. This constant spinning is more than just a quirk of our planet. It's essential for life itself. The rotation creates our day-night cycle, regulates global temperatures, and influences weather patterns. It's woven into the very fabric of our existence. So, what would happen if this fundamental force were to suddenly vanish? The moment the Earth stopped spinning, the consequences would be felt everywhere. One of the most immediate and dramatic effects would be the sheer inertia of everything on the planet. Think of it like riding in a fast car that suddenly slams on the brakes. Everything not firmly anchored to the bedrock would continue moving at the Earth's previous rotational speed. This means unimaginable winds, exceeding the force of the most powerful hurricanes, would rage across the globe. Buildings would be ripped from their foundations, trees uprooted, and the very landscape reshaped. But the devastation wouldn't stop there. The oceans, no longer held in check by the Earth's rotation, would surge as colossal tsunamis, swallowing entire coastlines in an instant. The planet's crust, under immense stress from the sudden halt, would buckle and crack, triggering earthquakes and volcanic eruptions on an unprecedented scale. Imagine winds so powerful they could strip the flesh from your bones. That's the reality of an Earth that's stopped spinning. The planet's rotation keeps the atmosphere relatively stable. Without it, the air would be free to move at incredible speeds. At the equator, where the Earth's rotational speed is the fastest, winds would reach supersonic levels, exceeding 1,000 miles per hour. These winds wouldn't be like any storm we've ever experienced. They would be a constant, unrelenting force, scouring the Earth's surface bare. Further from the equator, the winds would be slightly weaker, but still catastrophic. These winds would pick up debris, turning everyday objects into deadly projectiles. The air itself would become a weapon, a constant barrage of supersonic shrapnel. Section 5. Reshaping the planet, floods and recessions. The oceans, too, would react violently to a stationary Earth. The centrifugal force of the Earth's rotation normally pushes water towards the equator, creating a bulge around the middle of the planet. Without this force, the oceans would redistribute, flowing towards the poles. Coastal regions, already devastated by tsunamis, would be submerged under hundreds of feet of water. Entire continents would be reshaped, with some areas completely submerged and others newly exposed. The world map as we know it would be redrawn. This redistribution of water wouldn't be a gentle process. It would be a chaotic and destructive event, with massive waves crashing across continents, inundating everything in their path. The Earth's surface would be scarred by the receding waters, leaving behind a landscape forever altered. Section 6. The everlasting day sunlight's uneven grip. Perhaps one of the most disorienting changes would be to our day and night cycle. With the Earth no longer rotating, one side of the planet would be bathed in perpetual sunlight, while the other would be plunged into endless darkness. The side facing the sun would experience scorching temperatures, baking under the unrelenting glare. The opposite side would freeze in an eternal night, its surface locked in a deep freeze. This extreme temperature differential would have catastrophic consequences for the planet's climate and weather systems. The atmosphere, no longer experiencing the regular heating and cooling cycles of day and night, would become highly unstable. This would lead to extreme weather patterns, with scorching hot days followed by freezing nights, even in regions previously known for their temperate climates. Section 7. Life interrupted, adapting to a still Earth. In the aftermath of this global cataclysm, life on Earth would face its greatest challenge yet. The familiar rhythms of day and night, the seasons, and the delicate balance of ecosystems would be thrown into disarray. Most species, unable to adapt to such extreme and rapid changes, would likely face extinction. Plants, reliant on sunlight for photosynthesis, would struggle to survive in the areas of perpetual darkness. The food chain would collapse, with herbivores starving and carnivores soon following suit. Only the most adaptable organisms, those capable of withstanding extreme temperatures and finding new sources of food, would stand a chance. Even if some life forms could survive the initial onslaught, the long-term prospects would be bleak. The lack of a day and night cycle, the extreme temperatures and the disrupted weather patterns would make it incredibly difficult for life to thrive. Section 8. Could it really happen? The science of a stationary Earth. The scenario we've been discussing, while terrifying in its implications, is highly unlikely. The forces that keep the Earth spinning are immense, and it would take an equally immense force to stop it. To put it into perspective, the energy required to halt the Earth's rotation is greater than the energy released by the simultaneous detonation of every nuclear weapon on the planet. While it's theoretically possible for a rogue celestial object to collide with Earth and disrupt its rotation, the likelihood of such an event is astronomically small. Even if such a collision were to occur, it would likely shatter the planet entirely, making the question of a stationary Earth rather moot. So, while the thought of Earth grinding to a halt might make for a compelling disaster movie, it's not something we need to lose sleep over. The chances of it happening are infinitesimally small. Section 9. A fragile balance, Earth's delicate dance. While the complete cessation of Earth's rotation is highly improbable, exploring this hypothetical scenario underscores a crucial point. Our planet is a delicate system, an intricate web of interconnected forces. Even slight disruptions to this balance can have far-reaching consequences. The Earth's rotation, its atmosphere, its oceans, and its life forms are all part of this delicate dance. It's a reminder that we are inextricably linked to our planet's fate, and that our actions have the potential to disrupt this delicate balance. Understanding these connections and appreciating the forces that shape our world is not just an academic exercise. It's a call to action, a reminder that we must be stewards of our planet, protecting the delicate balance that makes life on Earth possible.